So we're going to continue section 7.2 with volumes of washers. So we did volumes of discs yesterday. Let me give you the formula for washers. So the washer method. And I mean, I'm assuming that you guys know, but like when we talk about discs, we are talking about things that look like this. Okay, so discs, they are solid. So something like that is considered a disc. Of course, it can have different shapes. A washer is basically the same idea. The only difference is that it's going to have a hole. Okay, so it's going to have something uh, where it has a gap inside. Okay, so there's going to be some kind of hole to it, whereas a disc will not. Okay, I'm not sure how many of you guys have ever worked with lug nuts or anything like that, but usually whenever you screw something into wood, they make you use a washer, because if you just put a screw through a piece of wood and just go as much as you can, you end up, the screw can keep going all the way through. It won't hold on to anything. So you use a washer as a stopper to basically say, okay, we're going to tighten as much as we can, and then this will just kind of push together, right? So you use washers like that. So that's the idea of a washer, is something that's solid yet it has a hole in it. Okay, so the washer method for us is this formula here. So V equal to pi integral from A to B of f of x quantity squared minus g of x quantity squared dx. So notice how in this case our functions individually are squared, not the difference of both functions. So with disk, you would subtract f of x minus g of x and then square everything. With washers, you square each individual function. Okay? Now, honestly, a lot of times people write this in a different way. Let me write it for you guys here. There's a lot of people that actually memorize the following formula instead. I guess I can, hold on, let me rewrite it this way. I'm just going to try to give it layers, okay? So f of x minus h of x quantity squared minus g of x minus h of x quantity squared d of x. Now, this is a more accurate representation of what a washer formula would look like, because it really depends on where my axis of revolution is. So if my axis of revolution is at 0, then my h of x is 0. Okay? So if my h of x is 0, then my formula looks like the top one. Right? It'll just be f of x minus 0 quantity squared minus g of x minus 0 quantity squared. So it's just f of x squared minus g of x squared. But if my axis of revolution is not 0, then there's going to be three main functions I have to focus on: f of x, g of x, and wherever my axis of revolution is. It's kind of the same with disks, but this one just looks a little bit more complicated. But, well, if you remember how I told you guys, this is a formula for a washer, okay? In essence, though, if I break this up, because this is an integration, it allows me to do the following. So notice I'm just breaking it up like this. Okay, so I made it into two integrals. Okay, what shapes are those two integrals? Notice the formulas. What are those? Those are disks. So a washer is made up of two disks subtracted. Okay, Do you understand why I tell you don't have to really memorize the washer formula? As long as you know how to do disks, you should be able to do washers. Okay? Because it is just a disk minus a disk. So if you can create your two disks, you should be good. Okay? You don't have to memorize any type of big formula because you already understand disks. So just use that knowledge. So here we go. Let me give you an example of something like this. Is this example 3 or 4? I think it's 3. Yeah. So example number 3. Find the volume of the solid formed by revolving the region bounded by and here are functions y equal to radical x and y equal to x squared about the x-axis. There's that word, about. So our axis of revolution is the x-axis. Okay, so go ahead and write that down. I'm going to jump back to yesterday's lesson. I want you guys to notice something important about yesterday's lesson. Okay, but right now I'm going to jump back to yesterday's lesson once you guys are done writing that down. Remember, it's just y equals to radical x and y equals to x squared. The word about is your key there. That way you know what you're going to be revolving about. Okay, and it's the x-axis. So let's look at yesterday's notes really quick. All right, so the two examples we did. I want you to notice how from intersect to intersect. So I'm putting them in green right there. I'll zoom in really quick. From intersect to intersect, the area was touching the axis of revolution, okay? You guys see that? So it was touching the x-axis. From one intersect to the other intersect, it was touching the x-axis. From one point to, if you were to draw a line from the green point to the other green point, that line would be touched by the yellow surface area. You guys see that? Okay. Let's go to the next example. Look at the two red dots. From red dot to red dot, those are connected by a blue line, right? And that whole blue line is being touched by the yellow area. You guys see that? Okay, look how it's different with washers. Okay, so right now, let me just kind of put this back to normal for that. Let's go to washers here. Let's graph this. Because this is how you can tell whether you're doing a washer or a disc. It's based on your picture. This is why I teach it based on looking at pictures. So we're going to do halves, okay? So here's 1 and 2. All right, so they put y equals x squared and y equals to radical x. So here we go. Radical x will go something like this. So that's y equal radical x. And y equals x squared will go something like this. And the area is right here. Now I'll zoom in just to make a point here. Here are my points of intersection. And here is my axis of rotation. They said the x-axis. Now look at your points of intersection. Are both points of intersection lying on the axis of rotation? Therefore, the whole yellow area is touching the axis of rotation. No. Those 2 points are not touching the whole axis of rotation. Okay? So, what I need to do is figure out how to work this problem because it's not a disk, right? So, I start drawing pictures. So this is the way I do it, okay? And you don't have to do it this way. You can just deal with the equations if you want to, but I highly recommend that you do it the way I'm about to do it, okay? So the first thing I do is I say, okay, every point of intersection, I'm going to create this invisible line connecting the point of intersection to the axis of rotation, okay? So the point of intersection to the axis of rotation. The first point is already touching the axis of rotation, so I don't have to worry about it. But the next one is not, so I'm going to actually do this. And that gives me my big area, okay? And this is what I'm talking about by the big area. So let me zoom out. What I'm going to do is I'm going to get a function that looks like this. So in other words, if I can draw really quick, I'm just going to really quick highlight something. This is what I just did right now. I highlighted all of that. All of it. Now remember, we're going to pretend like we're in kindergarten and your teacher's saying, I need you to cut the following shape, right? Now the shape we want to cut out looks like that. Okay, so what I did is I dropped vertical lines, or maybe you have to make the vertical line go up, it just kind of depends. But you're gonna create these vertical lines that touch your axis of rotation. Okay, not the x-axis only, but the axis of rotation. For us, it is the x-axis. And that creates a different shape. So notice that's the shape that it creates. Now, if I have that big shape right there on the bottom left, what do I cut out? What's it going to look like? The piece that I cut out, so that at the very end, I have this piece. So how do I use my scissors, right? Basically, that's what I'm thinking of. Well, what I need to cut out is this. Well, I guess I'll get to it right now. But this piece right here. That's the piece I got to get rid of, right? I got to get rid of that piece. And then I'll have that like teardrop looking shape. So let me go one more here. I'm going to get rid of a couple things really quick because I want to get rid of that highlight. So I'm going to do the big piece minus a piece that looks like this. And if I cut out that second piece, if this is a piece of paper on the left side and I cut out that piece, then my resulting shape will look like this. Does that make sense to you guys? All right, we're thinking of this visually. Okay, so we're saying, okay, if I drop that line, the whole area that I'm now seeing is over here. Okay, that's the whole area that I'm seeing. Now I need to cut, excuse me, that little piece in the middle, and that's going to give me the piece I want. So, if you're wondering, well, what the heck why am I drawing this stuff? By the way, I forgot to put y equals x squared for the blue one. I'm sorry about that. What's the top function for the first shape? So this right here, what is that function? Radical x. So that's y equals radical x. Now remember, we do top minus bottom. We're doing disks, right? What's my bottom function right here? What is it? Y equals 0. Yeah, not x squared, because x squared does the curving, right? So it's flat. It's flat against the axis of revolution. All right. My points from where to where? from 0 to 1. All right, let's go to the next picture. What is this function right there? X squared. So y equals x squared. What's the bottom function? Y equals 0. What's my interval from what to what? 0 to 1. Notice how it stays consistent, 0 to 1, right? Because we are going over the same thing. That's all I need to write my disk formulas, okay? So here we go. And if I write these formulas out, guess what? It's going to give me a formula for this thing in washer form. Okay, so let's do that. Let's write our formulas. The first formula for the first shape, it's going to be pi integral from 0 to 1 of radical x minus 0 squared dx. Notice I got the first shape and I just wrote a disk formula for it. Okay, it's top minus bottom. So radical x minus 0, quantity squared from 0 to 1, and you put a pi in the front of your integral. Now I'm going to do another disk for the second shape. So pi integral from 0 to 1 of top minus bottom. So top is x squared, bottom is 0, quantity squared dx. Now since they both share a pi and they both share the integral from 0 to 1, that means I can put them together. So volume is equal to pi integral from 0 to 1 of, well, let's see. Let's just write them together just so we can see them here. Radical x minus 0 squared. I'm not going to simplify anything, okay? I just want you guys to see that this, in fact, is a washer formula. Notice it's f of x minus h of x quantity squared minus g of x minus h of x quantity squared dx. That's the washer formula. But I didn't memorize it. I just did two disks and I put them together. And if that's what happens, then great. Who cares about memorizing another formula? Okay? Now let's simplify and let's work through this. So volume is equal to pi integral from 0 to 1. Radical x squared is just x minus x squared squared is x to the 4th dx. Now integrate and plug in numbers, so we get v equal to pi integral x squared over 2 minus x to the 5th over 5 from 0 to 1. Okay, plug in your values using the fundamental theorem of calculus, so we get 1/2 minus 1/5 minus 0 minus 0. Okay, and 1/2 minus 1/5, that's a 3/10. So volume is 3 pi over 10. So we got a lot of these little examples, okay, just so you guys know. It's not going to be just 2 examples and we're done. But right now, we do have a lot of examples to kind of go over. All right, so are we okay with this part right here? Any questions? All right, so let me see. I'm going to make a problem up, and I'm a little scared because every time I do it, it might not come out super easy, but I'd rather try to make up a problem really quick. So let me see. All right, let's try this. Am I in line? Yeah, I am. Okay. I wasn't sure if I was a little bit off. So here we go. example number 4. So we're going to find the region bounded by, I'm sorry, why did I say find the region? Find the volume of the region bounded by, I'm sorry, find the volume of the region bounded by the graphs of, and I'm going to put y equal to, let's do x squared plus 2. I'm just trying to think of this right now as I write it out. And y equal to 1 about the line y equal to -1. And we're going to graph this stuff. All right, so plus 2. So here we go. This is what it's going to look like when we graph it. Let's see. All right, so we'll go by halves again. So 1, 2, 1. All right, so let's draw the easy line first. Y equals to 1, so it's right here. And y equals to x squared plus 2. Oh, I think I may have to put some other things. Hold on, from 0 to 1. Give me a second. I'm just checking something really quick. Yeah, because these are not going to intersect. So, you know where I put right there about the line y equals to -1? Add the following after it. From 0 to 1. Okay, just put from 0 to 1. Because I just realized the way I wrote it, they don't intersect, so then I can't actually do this problem because it's impossible. There's no place for me to say, like, stop here. Okay, so I'm going to draw this, and I'm kind of out of range. That's okay. And they say from 0, or I'm telling you from 0 to 1, so let me see that 0 to 1 is right here. Okay, so 0 to 1. So let me color that in. And then they say about the line y equal to -1. So here's my axis of rotation. So if I were to draw this, if I were to say, like, okay, what does this kind of look like? Okay, what exactly am I seeing? What I'm going to see is a shape that kind of looks like this. When I'm revolving it, okay? And it's going to have a gap in between. And it should have the same size gap on the back. It's not perfect, but there you go. This is kind of the shape that we're going to be seeing. Right in the middle, okay, this line that's going right through here is y equal to -1, okay? That's where it's rotating, okay? Can anybody tell me what that line that's coming right through here is? What do you think creates the top of that hole? Y equals 1, right? That's y equals 1. Down here would be what? Y equals what? So how big is the hole from the middle to the top? What's the distance? 2 units, right? So it would be -3. Do I need to know that right now? No, I don't. Okay, it doesn't matter to this problem whatsoever. But sometimes they'll give you a shape and they'll say, look, this is what the shape looks like. And then you see it and then you start looking, you're like, okay, that means that this is this line and this is that line. And you start figuring out, my center, this is the distance of each line. So you can start, writing stuff out. But that's essentially the picture that they're giving us. Okay, once you start rotating, you're going to get that picture right there. Okay, so obviously a washer, right? There's a hole all the way through. Okay, so let's start drawing pictures. Now, remember, I told you to look at the intersections. Now, we don't have a lot of we have 4 intersections, right? In this case, we have an intersection here, and here, and there, and there. Okay, do those intersections touch the axis of rotation? No, so what I'm going to have to do, remember I told you, you're going to basically drop a vertical line so that it touches. It helps us create our picture. So I'm going to draw these a little bit smaller because this is going to be a really long picture, but at first, it's going to look like this. A really long drop, okay? Now, the yellow, and just to show you, the yellow is just about like right here, okay? So the rest of it is that white space that I don't have. But I'm going to include it. I'm going to say, okay, we're drawing this picture right now. This is what we're doing. We're drawing that big old picture right there. Okay, now I'm not going to tell you guys to color it in the way I'm doing because I can obviously just erase it with the click of a button. Okay, but that's what's happening. I got the whole thing. That's why I look at my intersection and I say, okay, let's pretend that this shape goes all the way to my axis of revolution. Okay, so there you go. All right, and then I'm going to subtract. Whoops, I'm going to subtract. What shape? The rectangle, the white rectangle, right? This shape right here. I'm going to get rid of this piece. All right, so I'm going to try to draw it kind of like based on the scale that I have. I'm going to get rid of that. And if I get rid of that, then my result is the top piece. Right? If I were to give you a paper that looked like this piece right here, and you got scissors and just cut the bottom rectangle, then you'd end up with that piece at the very end. This is the hardest part to doing these problems, is you kind of like getting a small picture and transferring it to, okay, here's a larger area and I'm going to cut a small area out so I can get the area I want. Okay? And it takes a little bit of an imagination. All right? But, I mean, once you get used to it, it's not that bad. So here we go. What is my top function here? X squared plus 2. So I'm going to put y equals x squared plus 2. What's my bottom function here? Y equals -1. Good. I always get people that'll yell out 0, which is normal because they think, well, 0, right? It's always 0. No, it's my axis of revolution. Remember that in the formula, the h of x was the axis of revolution. So it's my axis of revolution. So, all right. And then what's my interval from where to where? 0 to 1. Okay. Now, what about the box? What is this top function right there? Y equals 1. What's the bottom function? y equals -1, right? And then from where to where? 0 to 1. So there it is. I set up my formulas. They're all right there. They're right in front of me. All I got to do is put them together. Okay? So let's write this out. The volume for the first disk that I'm about to do, okay, the first disk, volume is pi integral from 0 to 1 of, all right, top function minus bottom function, x squared plus 2 minus -1 squared dx. Okay, so that's my first one. That's a disk, okay, not a washer. That's a disk. Minus pi integral from 0 to 1. Now I'm doing the box, right? That little rectangle now. By the way, people always ask me, like, do I have to do an integral for it? Because, you know, I can find the area of that. It's just 2 units high and it's 1 unit wide, so it's 2. Sure, you can put 2, but make sure you put 2 pi because there's a pi in front, right? But this is just going to be, what is it? 1 minus -1 quantity squared. Okay? So, let's see. This is going to be dx. So notice disk minus disk. All right, now let's put it together. So that's pi integral from 0 to 1. And by the way, if on an AP exam they want you to write the formula for the washer that's formed, don't leave it the way that it is right now. On top, you want to simplify it a little bit. That way they don't see like 2 disks put together. So what do we have here? We have x squared plus 2 plus 1. So that'd be x squared plus 3 squared dx. Okay, and then minus, oh, what am I doing? I'm sorry, not dx there. Let me use a parenthesis here. Right, because I'm combining these things together. Minus 1 minus -1, that's a 2 squared, so that's a 4 dx. So there's my washer formula. Now, if you really want to make it so that they're like, oh yeah, they do know it's a washer formula, you can always write 4 as 2 squared, and then they're going to be like, oh, look, they wrote it as something squared minus something squared. Okay? So you could do that if you want, but I'm just going to leave it as a 4, okay? Because it's just easier. I don't want to carry that. Now let's go ahead and start expanding, and then we integrate. So hopefully from here, the rest is easy. So from 0 to 1, we get x to the 4th plus 6x squared plus 9 minus 4. So volume is pi integral from 0 to 1. I guess I can simplify one more time. X to the 4th plus 6x squared plus, what is that, 8? No, I'm sorry, 5. Yikes. So there you go, dx. I don't know why I was thinking 9 minus 4 is 8. So now integrate. So volume is pi integral of x to the 5th over 5 plus 6x cubed over 3. That'd be 2x cubed plus 5x from 0 to 1. Now plug in your values. You get volume equal to pi. This is going to be 1/5 plus 2 plus 5 minus 0 plus 0 plus 0. So it's 7 1/5, which will be 36 over 5. So volume is equal to 36 pi over 5. We get out of here at what time? 34. We didn't finish. I got more examples, and I think the more I show you, I think the more comfortable you'll get. Okay? So I won't give you homework tonight. We'll finish tomorrow, hopefully, and then you'll get homework to do at that point.